they came to us and said, okay, well, we have a problem with sensitivity and robustness, because obviously stamping is a very sensitive subject, not just within ESI, but also in terms of physics. If you go and push and deform all of your pieces, you might end up with a very high nonlinearity. So you want to track this down numerically. And so what we do is basically look at the influence of different parameters in terms of sensitivity, to look at the speed of the punching force, to look at the friction, to look at, so if you can look at this here, those are the different parameters that you want in terms of process to optimize the force, the friction, and you want to look at the thinning, because beyond a certain level, thinning is just rupture. So it's just, it's just gonna break. Your piece is just gonna break. This is what you see on this example. The small red parts of your design. It just means that this part is no good, not anymore. So what you want to do is not only look at this one part and the distribution of the contour on this single part, but what you want to do is to run a design of experiment, varying the different parameters with regard to the different factors, and look at what we have on the right side. It's more of a visualization that will provide you with information on the blue, if it's within the constraint of the thinning, or if it's in the red, it means, well, it's no good, so you can just throw it away. And that's basically what the people on the manufacturing line are interested in looking at also. So this might be good to complement a current stamp analysis that is available. And so here's just also an example. You might want to show us, or maybe next time, how to browse through your ERF file. You've developed some here, small interfaces.
Well,
maybe we can show it
actually, if people are interested by browsing some ERF files, they can, as you told us already, just download the SciERF toolbox that is available on Confluence. And if they are interested, I can just provide them with a top-level application, Scilab application to make it more easy.
It's quite programmatic at the moment, but we can build visualization on, as you see on the left, on how those data are stored in different states and so on. And so this is also for us, I think within ESI, it's very important to address the subject of sensitivity analysis, because well, our competitors, they do such kind of thing. So if you look at Autoform Sigma is basically meaning that they are doing a bunch of simulation and looking at those parameters. And this is what matters a lot for the end customer. So if we are able together to work on such subjects, I believe it will make better ESI solutions. Same for additive manufacturing. Here, what we were looking at, it's, for instance, the distortion at the macro level of the solution that is now available. So here, for instance, how we need to print, or maybe, manufacture the piece in terms of angle in order to minimize the distortion. So here we have some very good-looking representation that were performed by Philippe. So Philippe was looking at the different orientation. Here, just looking at some configuration. So it's just some discrete values of the angles that he took, and look at the downwards support, the height, the real